Hi all. So in this video we are going to discuss about the problems on the root locus. So the first problem is a unity feedback control system has an open loop transfer function g of s is equal to k divided by s into s square plus 4s plus 13. Sketch the root locus. So if you're asked to sketch the root locus, the first step we have to do is we have to locate the poles and zeros of the function. Okay, so we have to find what are the poles and zeros here. So by observing this figure, we understand that only poles are there. There are 3 poles. Okay, there are 3 poles and there are no zeros here. Okay, so it is a system with 3 poles. 3 poles means because the highest power of the s will be, okay, if you are multiplying this s internally, it will give it as s cube. So there will be 3 poles. Okay, and no zeros are here. So normally we know that a root locus will start from a pole and end in a zero. Okay, so here there are 3 poles, so 3 root locus branches will start and there are no zeros here, so all the root locus branch will end at the infinity zeros. Okay, at the zeros at infinity. Okay, so the first step is to locate the poles and zeros here by considering the equation. Okay, s into square plus 4s plus 13, it is clear that the roots are one is 0, it is equal to 0, and one is, by solving this we will get it as minus 2 plus or minus j3. That is, one is at minus 2 plus j3 and another is at minus 2 minus j3. Okay, and we can take the poles as p1, p2, p3, etc. p1, p2, p3. Okay, and we have to mark these poles on the graph sheet. Okay, so if you are drawing a figure like this, okay, take this as the real axis and this as the imaginary axis, j omega, and here it is plus j1 and it is plus j2 and it is plus j3 here, and here it is minus 1, then minus 2 and minus 3, like that. Okay, so we have to mark the poles. Okay, we have to mark the poles here. So the poles are, one is at 0, we know that 1 is at 0 is equal to 0, so the first pole we are marked at origin, and another one is minus 2 plus j3 and minus 2 minus j3. So minus 2 plus j3 will come here, so this will be the minus 2 plus j3, and minus 2 minus j3 will approximately come here. Okay, this will be minus j1 minus j2 and minus j3. Okay, so you can see there are 3 poles, one is at 0 and minus 2 plus j3 and minus 2 minus j3. Okay, and the next step, the step 2, is to find the root locus on real axis. Okay, we have to find whether is there any root locus is in the real axis. Okay, so for finding that we have to choose any we have to choose some of the some test points on the real axis. Okay, so if you are taking a test point, okay, if you are taking a test point and you have to clearly observe at the right side of the portion, right side of that point, and if the total number of poles and zeros on the real axis are an odd value, okay, an odd value, then the test point will be a part of the root locus. Okay, So which means if you are taking a test point here, okay, listen carefully, that is at -1. If you are taking a test point here and we have to observe to the right of that point, that is right of that -1, okay, right of that -1, and if you are getting the total number of poles and zeros on the real axis as an odd number, then this point, that is this -1, will be a part of the root locus. Okay, so by observing that, we know that only a single pole is there. Okay, that is total number of poles and zeros to the right of this -1 is 1. So this is a point of root locus. Okay, so this is a part of root locus. And if you are taking any point, okay, if we choose any test point on the negative real axis, then to the right of that point the total number of real poles and zeros is 1. Okay, so which is an odd number. So hence the entire negative real axis will be a part of the root locus. Okay, and if you are choosing a point here, that is +1, okay, +1 or +2 like that, and we are observing to the right, we can't see any poles and zeros here. Okay, so this is not a part of the root locus. So we can say that this part, that is this negative real axis, will be a part of our root locus. Okay, so we can draw a figure. Okay, we can draw a root locus here in this negative real axis. Okay, so this is the root locus. Okay, this is the first root locus. And the next step, okay, that is the step 3 is step 2 we have already discussed. Step 3 is to find the angle of asymptotes and centroids. Okay, angle of asymptotes. So this angle of asymptotes will give the the direction of the root locus at which the root locus goes to the infinity zeros. Okay, zeros at infinity. And the centroid means at what point we have to draw these asymptotes. Okay, for finding the angles of asymptotes, the equation is plus or minus 180 into 2q plus 1 by n minus n. Okay, where the n is the number of poles and m is the number of zeros. Okay, so if you are taking that n minus m as p minus z, it is very easy to understand. Okay, instead of this n minus m, if we can use this p minus s, that is plus or minus 180 into 2q plus 1 divided by p minus z, then it is very easy to understand what is that p. If p means number of poles and z means number of zeros. Okay, that is here n means number of poles and m means number of zeros. Okay, and the value of q will be up to q is equal to 0, 1 up to n minus m minus 1 value, n minus m minus 1. So here the n, that is number of poles, is 3 and the m is 0. So the q will be 0, 1 up to 2. Okay, 0, 1 and 2. The value of q will be 0, 1 and 2. Okay, and we have to find the angles for each of the values of q. Okay, that is when q is equal to 0, we will get the angle as plus or minus 180. Okay, plus or minus 180 into 2q, that is instead of this q we have to place 0 here, so it becomes plus or minus 180 by 3 and we will get it as plus or minus 60 degree. And when q is equal to 1, it becomes plus or minus 180 into 3, okay, divided by 3, so it is plus or minus 180 degree. And when q is equal to 2, the angle is plus or minus 180 into 5 by 3, so it is plus or minus 300, and which it is equal to minus or plus 60 degree. That is plus 300 means minus 60 degree and minus 300 means plus 60 degree. Okay, so we can write it as like that. Okay, and the centroid, how can we find the centroid? Centroid means the equation for centroid is sum of poles minus sum of zeros by n minus 1. Okay, so the sum of poles, we have to add all the poles here, that is 0 plus minus 2 plus j3 minus 2 minus j3 minus sum of zeros. Sum of zeros, we can't see any zeros here, so we are taking it as 0. We are taking it as 0 here, and n minus m value, that is n means number of poles, it is 3, and m means number of zeros, it is 0 here, so 3 minus 0, 3, and we will get it as minus 1.33. Minus 1.33 will be the centroid. Okay, so in the graph we have to draw we have to mark the centroid, and from the centroid we have to draw the asymptotes. Okay, and here you can see we have marked the centroid at minus 1.33. This is the minus 1.33 point. Okay, that is in the same graph. Okay, that is in the same graph. We can mark the centroid. Okay, we can mark the centroid at minus 1.33 area, so approximately here. Okay, approximately here this will be the minus 1.33, and from that we have to draw the angle of asymptotes, and the angle of asymptotes is plus or minus 60 and plus or minus 180, and again minus or plus 60 degree. Okay, so these two are same. Okay, plus or minus 60 and minus or plus 60, both are same. Okay, so we are going to draw the angle of asymptotes here. So from this point draw a line, draw a dotted line with an angle of plus or 60, and also draw a line with the minus 60. Okay, so this complete, and plus or minus 180. So plus or minus 180 means the real axis itself. Okay, no need to draw that, it is already there. Okay, and again minus or plus 60, minus or plus 60 will be equal to the same lines. Okay, so in this we can draw the graph as, okay, we are drawing by taking an angle plus or minus 60. Okay, so this will be the asymptotes. Okay, this will be the asymptotes. So we have marked the centroid here, and also we have done the asymptotes. Okay, and after that we have to find the breakaway and the break-in points. Okay, breakaway and break-in points. That is, the breakaway point means whether the root locus, okay, the root locus is break away from the real axis or not. We have to find that. Okay, so breakaway or break-in points either lie on the real axis or exist as complex conjugate pairs. That is, if there is a root locus on real axis between two poles, okay, between two poles, then there exists a breakaway point. Okay, if there is a root locus on real axis between two zeros, then there exists a break-in point. Okay, so here so in this figure we know that only there are three poles. Okay, only there are three poles, so it won't contain a break-in point in the real axis. Okay, but we have to prove that. Okay, we have to prove that if suppose if there is a pole here, if there was a pole here, okay, in this point, then there will be a root locus in between these two poles. Okay, that is, if you are placing a pole here at minus 3, then between this 0 and minus 3 there is a root locus. Okay, so there is a chance for breakaway. That is, the root locus is breakaway from some points in the real axis. Okay, so if there are two poles, if there is a root locus between two poles, then there is a breakaway point. And if there are two zeros here, okay, instead of these poles, if you are marking two zeros here, then there is a break-in point will be here. Okay, so here, for proving that, first we have to find the characteristic equation of the transfer function. We know that the g of s is given as k by s into s square plus 4s plus 13. So the closed loop transfer function c of s by r of s will be equal to, by using the equation we will get it as k by s into s square plus 4s plus 13 plus k. Okay, and the characteristic equation is the denominator part, that is s into s square plus 4s plus 13 plus k is equal to 0. Okay, and we are just rearranging to get the value of k. K is equal to minus s cube minus 4s square minus 13s. Okay, then on differentiating the equation of k with respect to s, we get as dk by ds equal to minus of 3s square plus 8s plus 13, and we are equating this value to 0. Okay, and we are going to find the value of s. that is minus 3a square plus 8s plus 13 is equal to 0, and by solving that we will get the s as minus 1.33 plus or minus j 1.6. okay, 1.6, and we have to check whether these 2 points, okay, that is minus 1.33 plus j 1.6 and minus 1.33 minus j 1.6 is the breakaway point or not. Okay, for checking that we have to check for k. Okay, that is in the equation of k, this is the equation of k. First we have to substitute the value minus 1.33 plus j 1.6 instead of this s. Okay, and check whether this k is a positive real or not. Okay, and if it is a positive real value, then this point, that is minus 1.33 plus j 1.6 will be a breakaway point. Okay, if this k is not a positive real value, then this 1.33 plus j 1.66 will not be a breakaway point. Okay, then after that we have to check the value for k for minus 1.33 minus j 1.66, because two roots are there. Two roots are here for s. We have to check for k for all these two roots. Okay, so first we are taking when s equal to minus 1.33 j plus j 1.66, we will get k as a large value, and we are getting it as it is not a positive and real. Okay, there are some j terms are there, is imaginary terms are there, so we can't say it is a real. Okay, so it is not a positive and real. And also if you are substituting the value of minus 1.33 minus j 1.66 in the same equation of k, it will also an imaginary part will be there, so they are not positive and real. Okay, so since the values of k for s equal to minus 1.33 plus or minus j 1.66 are not real and positive, these points are not an actual breakaway or breaking point. Okay, so the root locus has neither breakaway and not break-in point, so this has to prove here. Okay, by observing the figure, by observing this figure itself, we get a clear idea about the root locus. There is no breakaway point will be here, but we have to check for that. Okay, using this kind of equations we have to check for that, that is whether it contains any breakaway point or not. Okay, and after that we have to find the next step, that is step 5 is to find the angle of departure. Okay, so the angle of departure can be found using a simple equation. Okay, that is first we have to if there are complex poles, okay, if there are complex poles, then there will be an angle of departure. Okay, and if there are complex zeros, then there will be an angle of arrival. Okay, so the angle of departure, okay, angle of departure can be found using the equation, that is 180 minus, okay, that is angle of departure from a complex pole can be found using the equation 180 minus sum of angles of vector to the complex pole. That is, if you are considering this as a complex pole, you have to find the sum of angles of vector to this complex pole from all other poles. Okay, so we know that three poles are here. Okay, so if you are going to find the angle of departure from this pole, we have to draw the lines from all other poles. Okay, and we have to measure the angle. Okay, so that is we have to add here, that is 180 minus sum of angles of vector to the complex pole from all other poles. Okay, then plus sum of angles of vectors to the complex pole from all other zeros, but here no zeros are there, so we are eliminating that time here. So only 180 minus sum of angles of vector to the complex pole from all other poles are only here. Okay, so two other poles are there, that is theta 1 and theta 2. We have to find what is theta 1 and theta 2. Okay, so theta 1 will be find using the equation, that is this is the angle theta 1. Okay, either we can use the protractor for measuring that, or we can use a simple technique, that is this angle here, listen here. So this angle can easily be found using the equation tan inverse 3 by 2, because this is 3 and this is 2. Okay, so tan inverse 3 by 2 will give this angle. Okay, so 190 minus that angle will give the angle theta 1 here. This is the theta 1. So theta 1 is equal to 180 minus tan inverse 3 by 2. It is 123.7. And theta 2 is exactly, it is the complex conjugate of this complex pole. So it gives a plus 90 degree. Theta 2 will be 90 degree. So by substituting that value, we will get the angle of departure as minus 33.7. So the root locus will start from this pole and will go to infinity. That is the at what angle the root locus start from this pole is can be explained using the angle minus 33.7. okay, and the angle of departure of the root locus from this pole that is P3 will be just opposite to the value here. Okay, that is here it is minus 33.7 and here it will be plus 33.7. okay, so that is the angle of departure, and after that we have to find the crossing point on imaginary axis. Okay, crossing point on imaginary axis. So for finding the crossing point on imaginary axis, we have to consider the characteristic equation again, and we have to substitute for s equal to j omega, and we will get the equation as minus j omega cube minus 4 omega square plus 13 j omega plus k is equal to 0. okay, and after that we have to equate the imaginary parts here, only the imaginary parts, the coefficients of the imaginary parts to 0. That is minus omega cube plus 13 omega is equal to 0. From that we will get the omega as plus or minus 3.6. okay, so the crossing point of root locus on the imaginary axis will be the plus or minus j 3.6. okay, plus or minus j 3.6, and the value of k corresponding to this crossing point will be found using this equation. That is, here we have equated the imaginary part, here we have to equate the real part of this equation to 0. The real part will be minus 4 omega square plus k is equal to 0, and we have found the omega here, and by substituting the values, the k will obtain it as 52. okay, so the value of k at this crossing point, that is plus or minus 3.6, is 52. okay, so this is the limiting value of k. So after that we are drawing the entire graph like that. okay, that is 3 poles are there, and we have drawn a root locus here, that is starting from this pole at origin and going to the infinity. This is the first root locus, and we have drawn the asymptotes at from the centroid minus 1.33. These are the asymptotes, and we have drawn the angle of, we have found the angle of departure as minus 33.7. okay, so from this pole just draw an angle minus 33.7. at that direction the root locus will start. okay, and from this pole we are drawing an angle plus 33.7, and in this direction the root locus will start. okay, after starting, the root locus will go parallelly with the asymptote, and it will cross the imaginary axis at plus j 3.6 and minus j 3.6, that we have already found here. okay, so it will cross it at minus j 3.6 and plus the j 3.6, and will go to the infinity to end at the 0 at infinity. okay, so this is the root locus branches. So 3 root locus will be there. One is in the negative real axis, and one is this, and another one is this. I hope all of you understand the problem well. So thank you.